So today we're going to talk about scientific notation, and this works really well when you have numbers that have lots and lots and lots of zeros in them. And it works great when you have very large numbers, and it works when you have very small decimals. Now, one thing I want you to notice, and you can see the two notes that we have here, is one, positive exponents are going to make large numbers. And negative exponents, they're going to make decimals. And these decimals are going to get super tiny, but it still works. So let's focus in on our notes. Now this right here, this is the outline or the framework that we're going to use to represent our scientific notations. One, you have a base, that's where you're going to put that number, and it's always going to be times 10, and then you're going to have a place for your exponents. Now I realize these little squares are very tiny, so you might have to write outside the box. So let's talk about positive exponents first. So you're going to want to find your decimal, and of course your decimal is always at the end of your number. It's always in the back, right behind the ones place. And you are going to count how many spaces or numbers you have behind that first number. And in this case, 2 is going to be our whole number. And we're going to write 79. But how many place values did we actually move? Well, we moved 1, 2, 3. So our exponent is going to be 3. So let's look at our next example. Again, there's where your decimal is. We're going to stop right here behind the first one. So that's 1, 2, 3, 4, 5, 6, 7. So this is 3 2/10 times 10 to the power of 7. Now you're always going to go behind that first number. That first number is always part of your base. I mean, it's got to be there. And the decimal is going to end up being behind that first number. So again, there's where your decimal is going to end up. And it's 1, 2, 3, 4, 5, 6. So it's 6.7 times 10 to the power of 6. Now, if you look right here across, these numbers are already written in scientific notation, and we need to write them in standard form so that it looks like a real number. Now, here's your decimal. Your exponent is going to tell us that we need to move to the right 5 places. Got to make it bigger. So we start here, and there's 1, 2, 3. Oh no, we have to move 5 because that's what our exponent is. Simply just add 2 zeros. So it's 7, 9, 0, 2, 0, 0. And then make sure you put your commas in the appropriate spot. So let's look at this next one. Again, there's your decimal. Your exponent is telling you to move to the right 4 places. So there's 1, and you're going to need to add 3 zeros. So 8, 2, 0, 0, 0. And again, place your commas in. Now, the next one, you're only going to have to move it 2 spaces to the right. So there's 1, 2. So it's 2, 19. Sometimes they won't have any zeros in it. Now, negative exponents. Please, please, please remember that when you have negative exponents, you are going to end up having decimals. So let's write that down. You're going to have decimals here. All right, very important. Now decimals, or negative exponents, can be a little tricky. Now the way I tell students this when we're first starting out this is put an arrow right behind your first non-zero number. So in this case, it's going to go behind the 8. That's where your decimal is going to go in your number. So 8.4. But how many numbers did you move, or in between the decimal and your arrow that you drew? 3, exactly. So that's going to be 10 to the negative third. So again, put a little mark there so you know where to stop. So that's 4.72 times 10, and you went 1, 2, 3, 4, 5. So that's the -5. Alrighty, so let's write it in standard form. Now, with negative numbers, you're moving to the left. So there's 1, but you'd have a -5. So you're going to need to add some zeros. And I'm scared to squeeze it in here because I'm scared it's going to write over it. So 0.0234. So if you look, put my pencil here. If I would have put my arrow where my decimal is, you can see that there are 5 spaces, 5 numbers between my arrow and my decimal, and that's what needs to happen. So here again, you're starting here, you're moving forward 1 spot. So that's 0.855. Very good. So that's how we go from standard to scientific notation and back. Now lastly, we have to compare. And the easiest way to do it is start off with your exponents. As we can see, this number right here is our exponent, is -10. That's smaller than 5 and 5. So that's going to be our least number. Now here you have 2 numbers that have the same exponent. So now we're going to go to our base. Which is smaller, 5 and 87/100 or 2 and 99/100? Well, the 2 and 99/100, of course. 2.99 times 10 to the 5th. And then the same way with the other ones. Don't forget your decimals and your exponents. All right. So now let's look at number 2. Again, start with your exponents first. So we see that this -8 is our smallest of the 3 numbers. Followed by -3. And then 10 to the 8th. All right, there's our notes on the on scientific notation.